All right, welcome back for segment 2 of chemical reactions and quantities. In segment 1, we looked at chemical reactions, starting with a sentence, turning that into a word formula, and then finally into a skeleton equation. Now, on assessments, you will not be asked to come up with word equations. You will be given sentences and asked to come up with complete and balanced equations, and that's what the second segment is going to tackle. The second segment is going to tackle balancing chemical equations. So again, we would be starting with a skeleton equation. We will have built all of the pieces, going from names to formulas and having all of our symbols in. And the next thing we want to do is balance the equation, which means we have to recall we cannot create or destroy atoms. And so we led off with that in segment 1. We said, okay, here it is, Fe. There was 2 of them in the beginning and only 1 in the end, and that can happen. And so the way we fix that is by balancing the equation. So that way all the atoms that we start with, we end with. Okay, so a balanced equation then has the same number of each element on both sides of the equation. Now we'll start with some simple ones. So here's carbon plus oxygen going to CO2. Now here you can see oxygen is diatomic. We depict that by showing it connected, so the 2 oxygens are connected together. Now to make this reaction happen, first we're going to break that bond and then connect the 2 oxygens to the carbon to give us CO2. Now when we write that out, it would look like that, C plus O2, arrow CO2. Now if I count that up, I can see I have 1 carbon in the beginning, 1 carbon in the end, 2 oxygens in the beginning, and 2 oxygens in the end. Now that equation is already balanced, so we don't have to do anything to it, we would just let it go as it is. Now what if it's not already? So carbon can react with oxygen to form not only CO2, but CO. So just like when you burn gasoline in your vehicle, you can make CO2, but you also make carbon monoxide. And so now our formula would be C plus O2 goes to CO. Now here we can see we have 1 carbon in the beginning, 1 carbon in the end, 2 oxygens in the beginning, but only 1 oxygen in the end. Now if I just simply put a 2 in there so that I have 2 oxygens, that would be the last equation we just looked at, which would be CO2. Now chemically, carbon dioxide is very different than carbon monoxide. All right, so I can't just put a 2 in there because then that changes the reaction, and then it's no longer the reaction we're studying. So what can I do to fix this then? Well, in order to get an oxygen on the product side, the only thing I can do is add more CO. And so that's what I'll do. All right, I can't change the formula. That describes what's there, but I can actually multiply what's there. So rather than having 1 CO, now I can have 2 COs. Now when I do my count, I can see I have O2 on one side and 2 oxygens on the product side in the form of CO. Now, that means I made an extra CO, but the problem then becomes, well, where did that extra carbon come from? Well, it must have been there in the beginning. And if it was there in the beginning, then really what I had was 2 carbons plus O2 going to 2 CO. So I must have started with those 2 carbons, and then my formula becomes 2 C's. Notice it's a coefficient 2, not a subscript 2. So the subscripts, as we see here, tell us that it's going to be bonded together, so the CO is connected. The coefficient, which we have here, is simply saying I have 2 of these things. And so here I have 2 individual carbons. We see this again on the product side. We have 2 COs. Now the CO is a molecule, it's connected, and we see that up here. But we have 2 of them, coefficient 2. So there's 2 individual molecules, right? Hopefully that makes sense, the difference between a coefficient and a subscript. Subscripts say you're connected together and there's multiples in one compound. Coefficients say I have multiples of whatever is there, whether it be an individual atom or whether it be a compound. All right, so what are the rules to balancing? Well, number 1, you want to write correct formulas for everything. Right? So products, reactants, the whole 9, they all have to be correct. That's what we just studied. So naming compounds, making formulas, those were important because they're going to carry on to the sentences, and you have to be able to convert those names into the correct formulas, or else you have no chance at balancing your equation. The next thing you want to do is count the number of atoms of each type appearing on both sides. Right? So if I have 5 on one side and 2 on the other, that's not a problem, except we're going to have to fix that by balancing. And so we'll balance those elements one at a time by changing the coefficients, not the subscripts. At the end, we'll check to make sure that it's balanced. Some things you should never do. Never change the subscript to balance an equation. If you change the formula, you're literally describing a different reaction. So for instance, if I take H2 plus O2 and I want to form peroxide, then that would be H2O2. But if I'm forming water, H2O, it's going to be very different. And I'm sure you may have brushed your teeth with peroxide, but nobody goes around drinking 8 glasses of peroxide. That would be very bad for your stomach, so don't try that. Never put the coefficient in the middle of a formula. So if you're trying to get around something and say, well, I only need 2 chlorines, so I'm going to put the 2 in the middle. I don't want the 2 sodiums, just the 2 chlorines. You cannot do that either. That will get you marked wrong. So make sure that if you're using a coefficient, you put it all the way to the front. And again, sometimes it takes a while to balance things. Sometimes they go really quick. And we're going to do some practice, and I've got some other methods to help you out with this. So let's look at that reaction. H2 plus O2 goes to H2O. Now, if you've never balanced before and you have no tools whatsoever on doing this, then I'm going to suggest that you make a table to keep track of everything. And so your table is going to look something like this. We have reactants, R, on one side. Then we're going to list off all the elements that are in the reaction, in this case, hydrogen and oxygen. And then we're going to have a P for products. Then what we're going to do is go back up to our reaction and take a look at it. So on the reactant side, we have 2 hydrogens. So there's your 2. On the reactant side, we also have 2 oxygens in the form of O2. Now on the product side, in H2O, we have 2 hydrogens and of course 1 oxygen. All right, now what we're going to do is simply go down our list and make sure we have the same number on both sides. Here we can see the 2 hydrogens, we're good to go. Oxygen, we're not. We need more oxygen on the product side. So what I'm going to do is I'm going to write a 2 in front of the water. So I have 2 H2O now. Now that's going to give me the 2 oxygens that I need, but it's also going to multiply the hydrogen. So now I'm going to get 2 times 2, or 4 hydrogen. All right, now at this point we only have 2 elements, but if I had a longer list and I had more elements, I would move on to those elements and make sure I'm getting those balanced next. Once I get to the bottom of the list, I'll come back to the top and start checking again. In this case, we only have the 2 things, so we're going back to the top immediately and we're going to fix the hydrogen right away. Now, in order to get 4 hydrogens on the reactant side, I'm going to put 2 in front of H2. Those 2 multiply each other, and now we have 4 hydrogens on both sides. That 2 does not affect the O2, so I don't need to change the 2 in front of my oxygens on my table. That can stay the same. All right, at this point, we can see we have a balanced chemical equation. Now, as you're working on these and you're submitting work, make sure you realize that's the answer we're looking for. So if you're told to complete and balance the following reactions, or you're told to balance the following reactions, what we're looking for is that, the balanced equation, not the table. Just having a good looking table is not going to get you points. You have to have a balanced chemical equation. All right, let's do some fun practice. CH4 plus O2 goes to CO2 plus H2O. So again, you might want to start by making a table. So I'll go reactants, products, and in this reaction I have carbon, hydrogen, and oxygen. So carbon, hydrogen, oxygen. On the products I have carbon, oxygen, hydrogen, oxygen. I like to just make sure I have the same elements on both sides. That way I know I've written this correctly. I didn't make any mistakes with maybe naming, or I've missed an element or something along those lines. Now, at this point, I look at the reactant side. I have 1 carbon. So I'll put a 1 here. I have 4 hydrogen, and I have 2 oxygen. Now on the product side, I again have 1 carbon. I have 2 hydrogen, and I have 3 oxygen. In case you're not sure of that, you have 2 oxygen here, and we're going to add this. This is math, plus 1 oxygen. All right, so there's what I'm starting with. I don't need to do anything to carbon. It seems to be balanced already, 1 to 1. The next thing I'm going to do is fix my hydrogen. So I'm going to go up here and I'm going to put a 2 in front of the water. That's going to give me my 4 hydrogen. Now it also is going to change my oxygen. Here it's going to give me 2 plus 2, 4 oxygen. All right, so hydrogen's fixed. Next thing is oxygen. So this tells me I have 2 oxygen on the reactant side, 4 on the product side. So I'm going to put a 2 in front of the O2. That's going to give me 4 oxygen. It doesn't affect anything else over here. So at this point, oxygens look like they're balanced. I'll go back to the top, and it looks like I have 1 to 1 for carbon, 4 to 4 for hydrogen, 4 to 4 for oxygen. So my table looks good. Now let's go up here and just double check. We have 1 carbon, 1 carbon, 4 hydrogen. 2 times 2 gives me 4 hydrogen. 2 times 2 gives me 4 oxygen. 2 plus 2 times 1 gives me 4 oxygen as well. That reaction should be balanced. All right. Next, we're going to take a look at our first little trick. So a trick of the trade. Now we've seen these polyatomics before, and here one is just popped in. So we have silver nitrate plus copper. There it goes. Couldn't get the mouse to show up. We have silver nitrate plus copper is going to give us copper 2 nitrate plus silver. Now, if you know the name here or not, doesn't matter, but if we were given the name, we need to come up with the correct formula. Now, the trick I'm talking about is right here. Notice that the nitrate is in parentheses, and the nitrate didn't break apart. We had 1 nitrate over there. So what we're going to be able to do is when we set up our table, we don't need to balance everything. What we can do is balance silver. Since the nitrate didn't break apart, I'm going to balance nitrate, NO3. Now, if my nitrate had broken apart, I would have to do it separately, nitrogen and oxygen. In most cases, nitrate's not going to break apart. It's going to be on both sides. So as long as you see it on both sides, you can treat it as an individual element. Now, if you don't recognize it and you decide you're going to balance the nitrogen and the oxygen, it still should balance. The only thing is it might take you a little longer because you're balancing individual parts instead of units. Obviously, it's going to be easier to balance 3 things than a whole bunch of things. The next thing we have is copper. Now when I go to write this out for my reactants, I have 1 silver and 1 nitrate and 1 copper. On the product side, I have 1 copper, I have 2 nitrates, and 1 silver. So now to balance this, I don't need to do anything to silver, but then I need to balance the nitrate. So in order to get 2 nitrates, I'm going to put a 2 in front of silver nitrate. That's going to give me the 2 nitrates I need, but it's also going to generate 2 silver. Now I'm not going to go back up and fix this right away. I'm going to go ahead and take a look at my copper. It says it's 1 to 1. And so I guess here, this 2 doesn't affect that copper, so that's still 1. And of course we have a 1 there, so we're 1 to 1, that's good. Now I'm going to go back to the top and start again. The silver says now it has 2, because that coefficient there multiplies that silver. So that means I'm going to need to put a 2 in front of this silver. That's going to give me a 2 there. Now that should suggest that it's balanced. That didn't affect the nitrates. This 2 was already here, and since this 2 went in front of the silver, it had no impact on the nitrate. The copper was also not impacted, so it's 1 to 1 as well. So according to the table, we should be good. So here we have 2 silver, 2 silver, 2 nitrate, 2 nitrate, 1 copper, 1 copper. This reaction is now balanced. All right. Now I do try to wean students off of the table as quickly as possible, but again, you can use it all semester long. It's just difficult that it takes up time and you're going to have other things you need to get done on exams and assessments, and I don't want you to spend your entire testing time working on trying to balance. And so I try to get you to practice plenty of balancing so that you don't need to use those tables. So I'm going to go ahead and put up a few more here, and I'm balancing them, but I'm not going to use a table. So here's magnesium plus nitrogen is going to give us magnesium nitride. Phosphorus plus oxygen to give us tetraphosphide decaoxide, cut the A off. And then we have sodium plus water goes to hydrogen plus sodium hydroxide. So if you want, pause it here, and then I'll give you a couple of moments, and then I'll go ahead and balance the equation so you have the answers. So again, I'll give you a pause here. All right, so if you've unpaused, you're ready to get some answers. So for this one, again, without using the table, I'm just going to do it straight across. I have 1 magnesium, 3 magnesium. So I'm going to go ahead and put a 3 right here. I have N2 and N2. This 3 doesn't affect the nitrogen, so I should be good. 3 magnesium, 2 nitrogen, 3 magnesium, 2 nitrogen. All right, for the next one, I'm going to put a 4 in front of the phosphorus. That gives me P4 plus O2. I need 10 of those. So I'm going to put a 5 in front of the oxygen. Now I have 4 phosphorus, 5 times 2 is 10 oxygen, 10 oxygen. Should be balanced. Now for this next one, you may have recognized water as having a polyatomic. So we can rewrite this water as HOH. And if you saw that, then you know you were probably able to balance this fairly quickly, because now you can see this hydrogen is what's being released there. So in order to get 2 of those hydrogens, I'll need to put a 2 in front of water. That's going to generate 2 hydroxides. So I'm going to put a 2 in front of sodium hydroxide. That's going to generate 2 sodiums. And so I'm going to put a 2 in front of sodium. So my final reaction then is 2Na plus 2H2O produces H2 plus 2NaOH. Now that reaction was probably a little bit more difficult to balance. And if you struggled with that, I'm not surprised. And if you got it, good job. Now we'll come back and look at some more balancing as we're going through. I'm going to go over one last technique and then we're going to get into types of reactions. All right, so some techniques. If an atom appears more than once on a side, balance it last. All right, so we're going to save it for the end. So for instance, when we look at combustion reactions, we get something like this, and we call this the doubling trick. C4H10 plus O2 goes to CO2 plus H2O. Now I'm going to slow it down, and I'm going to use a table again. So we have our reactants, we have our products, we have carbon, hydrogen, and oxygen. All right, so we have 4 carbons, we have 10 hydrogen, we have 2 oxygen on the reactant side. We have 1 carbon, 2 hydrogen, 3 oxygen on the product side. And now I don't need to worry about the fact that it's going to be the doubling trick. When I first start this off, I'm going to start off like I would any other reaction. So the first thing I'm going to do is balance the carbons. So I'm going to put a 4 in front of the CO2. That's going to give me my 4 carbon. Then I'm going to put a 5 in front of the H2O. That's going to give me my 10 hydrogen. Now I'm going to go ahead and recalculate those oxygen. I have 4 times 2 gives me 8 plus 5 times 1. 8 plus 5 is 13. All right, now here's where the doubling trick is going to come in. Carbon and hydrogen look good. Oxygen needs to be 13. Unfortunately though, it comes in 2s. So the only way I can make this work is by multiplying the 2 together. So 2 times 13 gives me 26. Now on the formulas, what I'm going to do is this. I'm going to take that odd 13 and I'm going to put it in front of the O2. And now we call it the doubling trick because I'm simply going to double everything else. This was an understood 1. I'm going to double that. That's going to be a 2. This 4 that we wrote in, I'm going to cross it out and I'm going to double it. So it's going to be 8. The 5 that we put in front of the water, I'm going to cross that out. I'm going to double it. It's going to be 10. And now this reaction should be balanced. Again, we can double check it. We have 2 times 4 gives me 8 carbon. 8 times 1 gives me 8 carbon. 2 times 10 gives me 20 hydrogen. 10 times 2 gives me 20 hydrogen. 13 times 2 is 26 oxygen. 8 times 2 is 16 plus 10. That's also 26 oxygen. This reaction should be balanced. Now, if you're struggling with any of this balancing, again, make sure you get in contact with me. Set up some tutoring or come to an office hour or student hour. I'll be more than happy to work through some problems with you. In the meantime, you can check out some of the worksheets I've posted. They have the answers at the back so you can see how you're doing. It also gives us a place to start from. So if you know you're struggling with one, but you're not struggling with all of them, you can simply send me that one and I'll take a look at it. All right, so that's going to complete the segment on balancing. Next, we're going to take our focus to the types of reactions. Here, you'll be able to predict your products, and so that'll be the next step. So again, we're going to start with naming, be able to name those compounds, turn them into formulas. Then we're going to set up a skeleton equation, and then we're going to balance that equation. Next, we're going to look at predicting products, so it's going to be yet another step in the sequence. All right, stay tuned for the next segment then. See you soon.